Let's look at factoring what we call a perfect square trinomial. Before we do that, I want to help you remember a couple things. So recall number one here. Let's recall that a perfect square, what a perfect square is, a perfect square can be written as something times itself. Okay, so for example, 9 is a perfect square because 9 is 3 times itself. X to the 6th is a perfect square because it can be written as x cubed times itself. Okay, x squared plus 6x plus 9 is a perfect square because it can be written as x plus 3 times x plus 3. Now, this last example here is a perfect square, but it's also a trinomial. So this is a perfect square trinomial. Alright? So any trinomial that factors as something times itself is a perfect square trinomial, right? Okay, good. Now let's practice something else that we need to remember here before we start factoring these guys. So recall number 2, how to square a binomial. So let's say we have x plus 3 squared. If I wanted to simplify that or multiply it out, I would think of it as x plus 3 times x plus 3. Okay? And I'm going to help you remember some things here. This is going to be a trinomial. 3 terms. Okay? So the first term out of x plus 3 times x plus 3 comes from x times x. So it will be x squared, and that's what's going to go here. The last term, the first term and last terms are the easiest. The last term out of this guy will be the 3 times the 3, the positive 3 times the positive 3, which of course is, 9. So that's going to go here. So we know where the x squared and we know where the 9 come from in this trinomial. Of course the 9 is positive. Where does the middle term come from? And this is where people sometimes have trouble. The middle term comes from taking this guy and doing a combination of things. Multiplying the x by the positive 3 to get a 3x, and multiplying this positive 3 by this x to get a positive 3x also, and those things are added together. So that's going to give us 6x. So that one is a combination of the inside pieces with the outside pieces. And so that's going to give us over here positive 6x in the middle. Okay? Alright, so I just want to remind you of that pattern because it's going to be key that we understand how to get the first, last, and middle terms when we multiply two binomials. Okay, let's get started with the factoring now. Let me give you this trinomial to factor. 81u squared minus 90uv plus 25v squared. Okay, we look at this trinomial, and the first thing we should think is there anything in common to all of it? And there's not. You can't factor anything out of all three terms. Then we try grouping. Okay? So that means 81, we have to multiply the 81 times the 25, and we get this obnoxious number. Okay? Now, we might come back to this later if we have to. We don't want to do it though. So now we're going to use something else to our advantage. We're going to say, okay, put all that aside, let's try something else. I notice that the first term and the last term are both perfect squares, right? So I could create those easily if I went to try to factor this immediately. So what I would do is I would say, okay, to get 81u squared, I would use a 9u and a 9u. That's going to give me this guy. Okay? And then, to get my 25v squared, I'm going to need a negative 5v with another negative 5v, or a plus 5v and a plus 5v. Okay, I've got to figure out which one. Now, I'm hoping that one of these two versions will work. Right? So let me write them out separately. Let's do that. So we're just trying this because I know I can create the 81u squared and the 25v squared very easily here. I'm just hoping that when I multiply this out I'll get the middle term, because if I do, then I'll be done. So the other option is 9u and 9u to get the 81u squared, and a positive 5v and a positive 5v to get the 25v squared, okay? Well, now I'm just going to check these to see if either one of these will work. Now, all I have to check is my middle term, which I know is a combination of these guys with these guys. Negative 5v times 9u is negative 45 uv. 9u times negative 5v is also negative 45 uv. And if I add those together, which is what I'm supposed to do, I will get my negative 90 uv. So this guy works. So I've factored my trinomial, and it in fact ends up being something times itself, so that means it's a perfect square trinomial. Now let's go ahead and try this version down here too. Positive 5v times 9u is positive 45 uv, and then here I will also get another 45 uv, and when I add those together I do not get my negative 90 uv here, I get positive 90 uv. So this guy does not work. And it also, if you analyze both of these, it makes sense that this guy, there's no way it's going to work. Everything here is positive. So when you multiply this out, there's no way you would ever get this minus here. So you could rule it out immediately. Okay, so we've factored 81u squared minus 90uv plus 25v squared, and we've avoided this obnoxious number over here that if we tried to do grouping. Now, it could be done by grouping, don't get me wrong, but I'd like to avoid those huge numbers if I can, and, in fact, at all cost. Okay, so we have factored it. This is the answer. It could also be written like this: 9u minus 5v quantity squared. So either one of those is perfectly acceptable. And that's how you factor a perfect square trinomial. You recognize the first and last terms are very easy to get, so you get those, and then you check to see if when you fill all that in, it gives you the correct middle term here.